Welcome to Gray Burr Werks. Today's video is from a site visit to the Sloss Furances in Birmingham, Alabama. I affectionately refer to this place as the Pig Iron Palace, and a reference is in the narrative as to why I call it the Pig Iron Palace. The introduction to ironmaking at Sloss Furnace from the visitor's brochure that I received from the visitor center refers to ironmaking as the classic Birmingham industry. The raw materials for making iron ore, limestone, and coal are available in abundance in the Birmingham area. And for some 90 years, men turned those materials into pig iron at Sloss. The heart of Sloss operations was a pair of large blast furnaces. A blast furnace is a cylindrical steel vessel lined with heat-resistant brick. Iron ore, limestone, and coke, which is made from coal, are charged into the top of the furnace, while super hot air is blasted upward from the bottom of the furnace. The blast of air burns the coke, releasing gases that extract the iron ore. The limestone acts as a flux or cleansing agent, removing impurities from the ore. Freed of impurities, the molten iron collects in the bottom of the furnace where it can be drawn off. The impurities, known as slag, are also molten, but are lighter than the iron ore and float on top of it. The slag is also drawn off periodically. In addition to the furnaces themselves, an iron-making plant consists of a large number of auxiliary machines and structures: blowers to pump the blast of air, stoves to heat the air, boilers to produce steam to drive the equipment, and a network of pipes that carry steam, water, and gas. Sloss Furnaces Visitor Center was built in 2014. This uniquely designed building houses exhibits, a theater education room, a gift shop, vent space, administrative offices, and restrooms. Read the Sloss storyboards that tell the history of the site at the far end of the building. The storyboards will give you some additional facts about the Sloss Furnaces. The number 2 cast shed once covered the area where the iron was poured from the number 2 furnace. Now it houses the world-renowned Sloss Metal Arts program. Here, artists teach classes and workshops, show students the modern process of pouring iron, create all types of metal art, and host public events. The Sloss Metal Arts program also hosts the National Conference on Contemporary Cast Iron Art and Practices every 2 years. This event brings over 400 artists from all over the globe to the Sloss Furnaces to learn and hone their craft as well as show off their skills. The Sloss boilers generated the steam that powered the facility. Sloss has 16 boilers, 12 on the left side and 4 on the right. The ones on the left were built around 1910, while the ones on the right were built in the 1920s. Inside of the boilers are large metal drums that would be filled with water. While the boilers could burn coal and natural gas to heat the drums, they primarily burn waste gas created inside the furnace during the iron making process. The gas was cleaned and pumped into the boilers and the hot blast stoves. The steam created in the boilers would be used to power the blowing engines and turbo blowers, the skip hoist, and the machinery in the Powerhouse. The stock tunnel had 3 pieces that worked together to get the iron ore, limestone, and coke into the furnace. Trains carrying materials from the mines and quarries would pull onto the stock trestle and unload the ingredients into a large storage bins below. The storage bins are above the stock tunnel. The stock tunnel is approximately 250 yards long and served both furnaces. Chutes in the tunnel would open and the ingredients would fall onto a scale car, which would weigh the materials and load the skip buckets located on the skip hoist. The ingredients would then travel up the skip hoist and into the furnace. The perimeter house is a 2-story brick building that sits right below the number 1 furnace, which was named after the temperature measuring instruments called perimeters that were mounted in the upstairs room. The downstairs room was a millwright shop where furnace repairmen worked. This building is the strongest built building on site and would be used to protect the workers if anything went seriously wrong with the furnace. This use of the perimeter house prompted the workers to call it the doghouse, saying the furnace would get mad at them and put them in the doghouse. Along one side of the water tower plaza are 6 tall cylindrical hot blast stoves. 5 are in a row, with the 6 around the corner creating an L shape. These stoves heated the air before it was pumped into the furnace. The stoves consist of steel shells lined with heat-resistant bricks and filled with a tall lattice of fire brick called checkers. Waste gas from the furnace would be burned in the stove to heat the checkers. The gas was then shut off and the air was blown through the stoves. The hot checkers heated the air to over 1400 degrees and large pipes carried the hot air to the furnace. In the first 2 rooms of the blowing engine building are 2 Ingersoll-Rand turbo blowers. These were brought to Sloss in 1949 and 1951. They are centrifugal compressors driven by steam turbines. These compact, efficient turbo blowers did the work of all 8 of the original blowing engines located directly behind the back turbo blower. The turbo blowers created very hot temperatures in the building, sometimes as hot as 120 degrees in the summer months. The original blowing engine building was built in the early 1900s, and it is the oldest building on site. The blowing engines stand over 30 feet tall and turn flywheels 20 feet in diameter at a rate of about 30 revolutions per minute. Although built in the early 20th century, the blowing engines represent the pinnacle of 19th century technology. Reciprocating steam engines such as these powered the Industrial Revolution. Each engine had a steam cylinder on the bottom and an air cylinder on the top. Steam drove the piston in the steam cylinders up and down, in turn driving the piston in the air cylinder. The moving piston pulled air in, compressed it, and pushed it out. These generated a large amount of noise. The decibel level would compare to that of standing in the front row of a rock concert. Lining the back wall are water pumps that move water throughout the site. The Powerhouse was built in 1922 and generated electricity for the plant as well as the Sloss quarters, which was the housing community built by the company for its workers. Steam from the boilers spun a turbine that powered a generator to produce an alternating current. The turbine and generator are on the upper level of the building, while the machines on the ground floor converted the alternating current into direct current. At the far end of the cast shed is the number 1 furnace. The original Sloss furnaces were created in 1882 and replaced in 1927 and 1929 by the furnaces you see today. Iron ore, limestone, coke, and hot air were continuously fed into the furnace, which would reach temperatures of 3,800 degrees. As the materials moved down and hot air moved up through the furnace, 2 products accumulated in the bottom of the hearth: molten iron and slag. The iron and slag were withdrawn or tapped through 2 holes called notches. About every 4 hours, the iron notch located at the base of the furnace was opened, allowing the molten iron to flow out of the furnace. Until 1931, Sloss used the floor casting method of making pig iron bars. The floor of the shed, which is now dirt, was once compacted sand. Mid would dig the molds for the pig iron bars into the floor. The design consisted of 1 main trough, or runner, going down the center of the floor. Secondary troughs would extend from the main trough, then the bars would extend from the secondary troughs. Workers thought the bars looked like piglets and the secondary troughs looked like sows. This is how they became to be called pig iron. Under the elevated walkway is the Ladle Car, a large steel kettle lined with heat-resistant fire brick. It transferred molten iron from the furnaces to the pig caster. As you look down past the Ladle Car, you can see the remains of the Sloss pig caster. The heart of the pig caster was a conveyor belt made up of shallow molds linked together. In operation, the conveyor belt was reminiscent of the trends of an army tank. The Ladle Car full of molten iron was pulled to the pig caster, and the ladle was tilted to pour out the iron. A system of runners carried the iron to the conveyor belt of the molds. As moving molds passed under the stream of iron, they were filled and sprayed with water. When the conveyor reached the end of its run and the molds turned over, the now solid pigs of iron fell out into the awaiting railroad cars. The Ladle Car and pig caster were brought to Sloss in 1931, making floor casting method obsolete. Sloss continuously used 5 million gallons of water per furnace every day to cool the furnaces, create steam, power machinery, and cool the molten iron and slag. Following a cycle, the hot water was then piped to the spray ponds. Here the water was cooled and then recycled through the plant. The slag flowed through a trough into the slag pit. Similar to lava from a volcano, the fiery molten slag, which was a waste product of ironmaking process, was flushed from the furnace every 2 to 4 hours. It was handled in one of 2 ways. Usually it was allowed to run directly into the slag pit, or it was run onto the slag granulator, sprayed with water to cool it, and then crushed. While it was the trash or byproduct of the furnace, it was still useful. Slag could be used to make drywall, insulation, and concrete. Sloss's slag pits also affected First Avenue North, which runs right next to the Sloss furnace. In 1920s, molten slag from the furnace would overflow onto the road and disrupt traffic. The road was then raised to keep this from happening. The road also has large shoulders so that people could park safely to the side and watch the iron and slag being poured from the furnace. Thanks for watching Gray Burr Werks, and please subscribe, like, and comment.